Hello everyone, and welcome to Biopedia. Today's podcast is the 66th official episode of Biopedia, discounting bonus episodes. As such, I thought I'd discuss a very famous event that happened 66 million years ago to fit with this milestone. Get ready to hear about one of the biggies in evolutionary biology, as we're going to cover the death of the dinosaurs. To start with, a quick primer on the dinosaurs themselves. The word dinosaur derives from the two Greek words dinosauros, or terrible lizard. The clade arose about 245 million years ago and roamed the Earth until 66 million years ago when the aforementioned extinction took place. About 1,000 species have been discovered. However, there are problems with accepting this as the true number because of the lack of completion in the fossil record, bias, such as chemical biases, in said record, and heterogeneity and expertise of the people sampling or the areas being sampled. Therefore, not everything has an equal probability of discovery. A 2016 paper used a Poisson distribution to calculate that 1,936 species of dinosaur lived on Earth during the Mesozoic. To feed some rough calculations of my own here, the International Commission on Stratigraphy notes that the Mesozoic lasted from 251.902 to 66.0 million years ago, or give or take 186 million years. Therefore, the above number means that about 10.4 species arose per million years. If we start the range at 245 million years, as I said earlier in this episode, this figure rises to 10.8 species. By contrast, a 1990 paper notes that modelling correcting for record bias yields 900 to 1,200 genera of dinosaur having ever existed. This paper held that, of the specimens found since 1824, 285 genera with 336 total species were probably valid. This number is probably outdated given the 33 years since publication at the time of recording. However, using this ratio of genera to species gives us a species range of about 1,061 to 1,415 species across the Mesozoic. This number approximately lines up with the 2016 figure, so we're likely looking at the high 1000s according to what seems to be scientific consensus in terms of number of species of dinosaur. However, this isn't the point of today's episode, although I can come back to these figures and how they were worked out in more detail later down the line. Instead, we're going to talk about the death of the dinosaurs. Get ready to talk asteroids. The asteroid or comet that struck the Earth 66 million years ago was about 10 kilometers across, or about as big as Everest. According to a publication from 2007 by Bottke et al., the number of asteroid strikes on the Earth and Moon combined has roughly doubled during the last 100 million years. They argue that an asteroid in the asteroid belt fragmented about 160 million years ago, with a date range here of 190 to 140 million years. The product of this fragmentation headed towards the inner solar system, and it is more than 90% certain that our friend the asteroid that killed the dinosaurs originated from this event. Therefore, it had probably been travelling through space for about 94 million years before it hit the Earth. The strike itself was at Chicxulub in Mexico, on a peninsula called the Yucatan. When it struck, it was likely going 108,000 kilometers an hour, and the strike had the same power as 1 billion nuclear bombs. It left a hole more than 160 kilometers across and went 40 kilometers into the Earth. For an account of what the dinosaurs would have seen when the asteroid hit, I'm going to turn to The Rise and Fall of the Dinosaurs by Steve Brusatte, which follows the story from the perspective of a group of Tyrannosaurus rex in Hell Valley. For context, Hell Valley is about 3,500 kilometers away from where the strike happened. A few weeks before impact, there would have been a ball that glowed in the sky, which got bigger and subsequently vanished for quite a bit of the daytime. However, it eventually returned a lot bigger than before. This was followed by a bright light that shone brilliantly for an instant as the asteroid compressed the atmosphere it was pushing into, and then a second, more powerful flash of light as the strike itself happened. After several moments, the Earth trembled and then splashed, energy flowing through it and making the Earth bounce repeatedly in a way that could throw the most massive dinosaur in the pack around. After the ground stopped rumbling, the sky slowly turned bright and red. Glass pebbles and small rocks came hurtling from the heavens, pelting the dinosaurs in a deadly rain. These projectiles also heated up the skies, turning the world into a furnace. Forest fires erupted from nowhere. Despite all of this, only a quarter of an hour has passed since the impact. After about an hour, the hail stopped and the sky grew colder again, now blackened by ash from still ongoing fire. About 2 hours and 30 minutes after the first blinding light, the sound from the 2 light pulses caught up to the dinosaurs into ear-splitting booms with enough strength to cause bodies of water to spill over. All over the world, the chaos continued. South America didn't have rains as bad as the North, nor did Europe. However, the dinosaurs living there had to put up with their own earthquakes, searing heat, and fire. A lot of the dinosaurs would have died in those first 120 minutes. In the middle of the Atlantic, waves double the height of the Empire State Building, so about 886 meters, sloshed around, bringing the dead bodies of animals such as plesiosaurs to the continent. In the Indian subcontinent, volcanic eruptions began in the Deccan. Anything that was in 1,000 kilometers of the Yucatan was destroyed. After just one day, the majority of the dinosaurs were gone. A fraction would limp on for a few more decades, but for years after the impact, the ash and dust from the day itself stayed in the sky and cooled the planet down. It took the toughest animals to make it through, as plants struggled to carry on and food chains broke down. Because of plankton limping through, the same cascade took place in the seas. Eventually, rain took the debris from the sky, but the rain itself was acid rain, which was still not able to take up the vast amounts of CO2 sent up with the debris. All of this led to years of cold being replaced with global warming. A paper from 1994 confirms the process here. They estimate that about 4 times 10 to the 16 to about 7 times 10 to the 17 grams of sulfur were thrown into the air. Put into ordinary units, that's 40 to 700 billion tons. This sulfur was turned into anhydrite rock by the event, but a smaller percentage was released as SO4 and SO3. This was then turned into sulfuric acid, with its descent back to Earth being the acid rain mentioned above. Linking this back to the cooling idea, they estimated that between 8 and 13 years of 10 to 20% less sunlight reached the Earth, because of these particles blocking it. This led to 300 watts per square meter of cooling, more than making up for the 8 watts of warming produced by carbon dioxide being produced. This led to about 10 years of cooling, which may have been followed by a few decades of heating because carbon dioxide stayed in the atmosphere for a long time. All of this combined meant that the few stragglers were picked off. The dinosaurs were gone. The thought I will leave you with is one about the probability of asteroid impacts and what can be done about it. In the distant past, 4 billion years ago, thousands of times more asteroids hit the Earth than during more recent geologic history. However, the Space Guard survey in the early 2000s still discovered 2,500 asteroids close to Earth, and about 1,100 are thought to be more than 1 kilometer across. In terms of concrete probabilities, a 1994 paper argued that there was a probability of 0.001% of an object about 2 kilometers across hitting our planet across the century to come. Should this happen, a sizable proportion of people on the planet would be killed, and the ecology of Earth would be negatively impacted. The authors noted that, although on an individual scale there isn't much risk, on a geological timeline the probability comes close to other calamities we see more regularly, meaning some way of combating it is needed. The authors listed the probability of death for United States citizens in a hurricane as being about 0.0016% and 0.0032% for floods, with the average figure for such asteroid impacts being about 0.0048%. An asteroid would only have to be 600 meters across, and a comet 400 meters, for worldwide disaster, although this is the smallest estimate. An impact like that which wiped out the dinosaurs, which is estimated to be able to kill 5 billion people, should only happen every 100 million years or so. But now, back to the idea of doing something about it. I'll leave you with the notion that sets of multiple spaceships could be employed to fire lasers at specific sites on an asteroid to cause material to sublime, or jump from solid through to gas without being liquid on the way, with the emission of this material causing the asteroid to be pushed away and change its course. So, we don't necessarily have to go the same way as our reptilian predecessors. As always, thank you for listening. Feel free to get in touch at the show's email address for any questions, comments, or topic suggestions for future episodes. Until next time, have a great week, everyone.